So this is the recursive sequences lesson. Previously when we dealt with arithmetic and geometric sequences, you guys were actually using sequences that were explicit rules or closed form, which means you could say, hey, find the 85th term, and you could plug in the number 85 and immediately get it. The idea behind recursive sequences is if you want to find the 85th term, you have to find all the 84 terms in front of it. So it's a little less practical, but it is something that we're still going to go ahead and look at. Whenever you write a rule for recursive sequences, you have to have it in two parts. The first part is you have to tell me the first term. Now this should look different because we're using the letter T, which is typically used when we do recursive sequences. So the first term is equal to 5. That's the first part of the rule. Then the second part of the rule involves what's actually going on here. The way you want to think about this is the term you want is equal to the previous term. So we show the previous term by subtracting 1 from it. If we wanted 2 previous terms or 2 terms before it, we would say n minus 2. If we wanted 5, it would be n minus 5. But the term we want is equal to the previous term. And what are we doing to the previous term? How do we get from each number? Well, we're adding 2 each time. So let's see an example of how this actually looks. Let's say find term 3. Well, let's use our rule. Term 3 is equal to term 2 minus 1. Or, sorry, 3 minus 1 plus 2. So that's equal to term 2 plus 2. Well, do you know that? No. That's why you have to find all the previous terms. So we're not even ready for this step. So if we want to find term 3, we got to find every term in front of it. Well, term 1 is equal to 5. Term 2 is equal to, now we can pull out our formula, term 2 minus 1 plus 2, which is equal to term 1 plus 2. When I simplify that, I know the value of term 1, I can substitute that in. So that would be 5 plus 2, which is 7. So term 2 is equal to 7. You can see that up here. Now we can find term 3. That's equal to, use this formula again, 3 minus 1, and then we're still going to add 2. So now we'd say term 2, because when we simplify that, that gives us term 2 plus 2. Well, now we know the value of term 2. Term 2 is 7. So 7 plus 2 is 9. So there's our final answer. Then we also have recursive sequences with our geometric sequences. So if you look, we're going to be doing 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So same rule. You got to start with the first term. And then you're going to write the rule. The term you want is equal to the term before it. And what do you do to the term before it to get what you want? Well, how do I get from 3 to 6? I'm going to multiply it times 2. So it's 2 times the previous term. So now let's go ahead and we'll find term 3 again. So remember, we got to find all the terms in front of it. So we're going to start with term 1 is 3. We're told that. Term 2 is equal to 2 times term 2 minus 1, which is really 2 times term 1. And we know term 1 from here. We know that term 1 is 3. So 2 times 3 is 6. Then we can find term 3. That is going to equal, and use this formula again, 2 times term n minus 1, or 3 minus 1. So that's equal to 2 times term 2, which is really equal to 2 times, what's term 2? Term 2 we just found to be 6. So 2 times 6 is 12. And you can check right here, yes, we got term 3.